Hi everyone, Assalamualaikum. In this video, we will discuss example 5 under integration by parts. In this example, we will discuss tabular integrals, right? Use integration by parts to solve integration of e to the power of 2x times x squared plus 3 dx, right? Now let me look the complete solution, okay? From the given question here, in this question, we cannot evaluate using partial fraction because there is no fraction and not a polynomial function. We also cannot use trigo subs because there is no radical function containing square root of a squared minus x squared, square root of a squared plus x squared, or square root of x squared minus a squared, right? Furthermore, we cannot use u substitution because there is no relationship between e to the power of 2x and x squared plus 3 in terms of derivative, right? And please note that despite the fact that this question is a product function, we cannot evaluate the integration using the product rule. It is because product rule can only be used in differentiation. Never use product rule to solve integration, right? The correct method to evaluate this question is using integration by parts, right? Right, from this question here, this question has a repeatable function, which is the exponential function. So, we can use tabular integral or integration by part formula, right? When we have repeatable function means exponential function or trigonometric function. So, we can use either tabular integral or integration by parts formula. Right? Integration by parts formula means integration of u dv equals to uv minus integration of v du. Right? For convenience, I will discuss this question using tabular integrals. Right? Alright, when we start using tabular integral, we need to use table with 3 columns. Right? 1, 2, and 3. The first column should be sign. The second column should be u. And the third column should be dv. Right? From u, we need to differentiate. And from dv, we need to integrate. Right? Alright, when we start to use integration by parts, we need to identify which function as u and which function as dv, right? In this case, x squared plus 3 is a. A means algebraic function. And e to the power of 2x is e. E means exponential function, right? Using ILATE rule, I-L-A-T-E, A come first. Okay? So, A should be U. Right? And the other function, which is exponential function, becomes dv. Right? So, now A should be U. A means x squared plus 3. Right? Which is algebraic function. The other function, which is exponential function e to the power of 2x become dv, right? Alright, and after that, we need to put positive sign in sign column, right? We begin with positive sign, then we alternate with the sign. So, we start with positive. Okay. Before that, to complete the row, so we need to differentiate first, right? Let's finish our column u first. So we know when we need to stop the row. Okay. So from u, we need to differentiate. So we differentiate x squared plus 3, which is equals to 2x, and then we differentiate 2x equals to 2, and we differentiate 2 equals to 0. Alright? Alright, question and answer. How many rows should we differentiate? The answer is until the derivative of algebraic function give the answer 0. If the given function has algebraic function, so when we solve or when we differentiate under column U, we can stop the rows until we get derivative 0. Alright, so we can stop here because in the fourth row here, when we differentiate, the answer equals to 0. Alright, and after that, we continue with column sign. Okay, we begin with positive and then we alternate with the sign. So start with positive, negative, and negative. Alright. Alright, and then from dv, we need to integrate. Okay, so we need to integrate e to the power of 2x. We can refer this formula. A here means constant. So now our a is 2. Okay, so when we integrate e to the power of 2x dx, the answer equals to 1 over 2 e to the power of 2x plus c. But we don't need to write plus c because we still not finish our solution. Okay, we just write half e to the power of 2x. Right? And after that, we need to integrate e to the power half e to the power of 2x. We still use this formula. Okay, when we integrate half e to the power of 2x dx, we can move out constant half. And then we have integration of e to x dx using this formula. We get half e to the power of 2x. Okay, and then we still have constant half in front here. Okay, and then plus c and half times half equals to 1 over 4. So we get the answer 1 over 4 e to the power of 2x plus c. But no need to write plus c because we still not finished our solution. Alright? And after that, we need to integrate 1 over 4 e to x. So we can move out constant 1 over 4 from integration sign. And then we integrate e to x dx using this formula. Okay, so we still have constant 1 over 4 and then times. When we integrate e to the power of 2x dx, the answer equals to half e to x plus c. And then we multiply 1 over 4 and half here. So we get 1 over 8 e to the power of 2x plus c. So we can put here. Okay, but no need to write plus c because we still not finish our solution. Right? Right, after that, we write the given question, integration of e to x squared plus 3 dx, okay, equals to, we multiply this, okay, positive multiplied by x squared plus 3 multiplied by half e to x. So we put here, okay. Right, we have x squared plus 3 and then times half e to x. Positive times positive equals to positive. Right? And after that, we multiply this. Okay? 2x times 1 over 4 e to x. Okay? We have 2x here and 1 over 4 e to x. Okay? And negative times positive times negative. Negative times positive equals to negative. Right? And after that, we multiply this. 2 times 1 over 8 e to the power of 2x. Okay, positive times positive equals to positive. Alright? And for the last row, we need to multiply in horizontal. Alright? But we need to put integration and dx symbol. Alright? So we multiply 1 over 8 e to x and 0 here. Okay? So we get 0. but we need to put integration and dx symbol. Okay? Negative times positive equals to negative. Right? And after that, we need to simplify. Okay? So we can put half in front and then e to x squared plus 3 and then minus 2 and 4 here we can simplify, so we get half x e to the power of 2x and then plus we can simplify 2 and denominator 8, so we have 1 over 4 e to x, and then when we integrate 0 the answer equals to constant. Okay, and when we put c here we can put positive sign because positive sign means we can use C negative or positive. Okay, but in general, we just put plus sign here. Okay. Alright. Why we get the answer C here? Because when we integrate 0, the answer equals to C. So we put plus C here. Because when we differentiate C, the answer equals to 0. So when we integrate 0, we will get back the answer C because integration is antiderivative, right? So we put plus C here, okay? Right, so this is the final answer. When we integrate e to the power of 2x, x times x squared plus 3 dx, the answer equals to half e to x is times x squared plus 3 minus half x e to the power of 2x plus 1 over 4 e to x plus c. Alright, the idea when we use tabular integral, we need to use table with 3 columns. Okay, first column is sin, second column u, and the third column is dv. Under u column, we need to differentiate, and under dv column, we need to integrate. And under sign column, we need to begin with positive sign and then we alternate with the sign. Alright, when should we start the rows? Okay, if the given question has algebraic function, right, when we differentiate, we need to stop when it gives the answer 0. Alright, so that's the idea to solve integration by part using tabular integral, right? Alright, now we look back at example 5. Okay, evaluate integration of e to x times x squared plus 3 dx, but this time we want to evaluate using integration by part formula, which is integration of u dv equals to uv minus integration of v du. Remember, when we have repeatable function, means when we have exponential function or trigonometric function, under integration by parts, we can use either tabular integral or integration by parts formula, right? So in this slide, we will discuss this question using integration by parts formula, right? So from the previous slide, when we integrate using tabular integral, we get this answer, right? Now, we integrate the same question using integration by parts formula, okay? So when we start use integration by parts, we need to identify the function, okay? The criteria of the function. Now we have exponential function, which is e, and algebraic function, which is a, right? So from Euclid formula, a come first, means a should be u, okay? So the other function means exponential function should be dv, right? So whichever function come first, that is equals to u, we can put in front, okay? So from here, we can write integration of, we put algebraic function in front because algebraic function now equals to u, okay? So integration of x squared plus 3, and then we put the function as dv beside dx, okay? So we put e to x beside dx here, right? So our algebraic function x squared plus 3 equals to u, and exponential function e to x equals to dv. And note, dx always include in dv. Okay, when we use integration by parts formula, we need to include, okay, dx with dv, right? Right. So from here, we can write integration by part formula, integration of u dv. Okay. And then it is equals to uv minus integration of v du. Okay. So from here, we have integration of u and then dv, and then we use this formula, it is equals to uv minus integration of v du. Then after that, we can list our u equals to x squared plus 3 and dv equals to e to x dx. Alright? From u, we need to differentiate to find du to put into this formula. Right? And from dv, we need to integrate to find v. Right? So when we differentiate u with respect to x, so we get du over dx, and that equals to, we differentiate x squared plus 3, it is equals to 2x. dx here come from over dx from left hand side, but we must move to right hand side because we need to write du as a subject because we want to substitute into this formula. Alright? And from dv, we need to find v. We need to integrate. Okay. So when we integrate e to x dx, the answer equals to half e to x. Okay. We use this formula. Now our a equals to 2. So that's why we get half e to x. Okay. Plus c, but no need to write plus c because we still not complete our solution. Alright. And after that, we multiply u and v from this formula. And we multiply v and du from this formula. Okay. So we have u equals to x squared plus 3 times v equals to half e to x minus integration of v equals to half e to x and then du equals to 2x dx. Right? After that, we can simplify 2 and 2 from denominator here. Okay. And we rearrange, we have half e to x and then x squared plus 3 minus integration of x e to x dx. Okay. X here, we cannot move out from integration sign because this is variable. Remember, we only can move out constant from integration sign. Never move out variable from integration sign. Right? So how to integrate this? Okay. From the previous slide, we get this. Okay. Alright. Half e to the power of 2x and then x squared plus 3. We don't need to integrate because there is no integration sign. But we need to integrate x e to x dx because we have integration sign here. Okay. Integration by part means inside integration, we still have another integration. Right? So in this case, when we use u substitution, let's say we choose u equals to x or u equals to e to x or u equals to 2x, we cannot simplify all variable x. Means that it is not suitable to use u substitution. Okay. It also not suitable to use integration using partial fraction because there is no fraction here. And it is also not suitable to use integration by trigonometric substitution because there is no term containing radical. Alright? So, the best way is we need to integrate using integration by parts again. Okay? And when we use integration by part, okay, we need to identify which function as u and which function as dv. So here we have x. Okay, x means algebraic function. And e to x means exponential function. So again, from Euclid formula, a come first. Okay, so whichever function come first should be u. And the other function should be dv. Right? So now our x equals to u. Okay, so from here, u equals to x equals to u, and e to x dx equals to dv. Okay, and notes, dx always include in dv. When we use integration by parts formula, we need to use dx in dv here. Okay, alright, and then we still have half e to x squared plus 3 minus integration of u dv, right? And then half e to x squared plus 3 minus from integration by parts formula, integration of u dv equals to uv minus integration of v du. And since we have negative sign here, so to avoid error, we must put bracket, right? And after that, our u equals to x, okay, from here. And dv equals to e to x, right? From u, we need to differentiate, okay? And from dv, we need to integrate, right? So, when we differentiate x, the answer equals to 1. Okay, dx here come from over dx from left hand side. Okay, so that's why we get 1 dx here, right? And then from dv, we need to integrate. So when we integrate e to x dx, the answer equals to half e to x. Okay, from this formula, right? Right, after that, we need to multiply u and v, and we multiply v and du from this formula, right? So we still have half e to x squared plus 3 because there is no integration symbol, so we don't need to integrate. Then minus u equals to x, v equals to half e to x, and then minus integration symbol, v equals to half e to x, du equals to dx, right? Right, so we check one by one. Our u equals to x, v equals to half e to x, and then minus v equals to half e to x again, and then du equals to dx, right? And then we have half e to x squared plus 3. We simplify and we multiply negative sign with bracket here. So we have half minus, and then half x e to x minus times minus sign equals to positive sign. And then at the same time, we can move out constant from integration sign. So we have half integration of e to x dx, right? And from here, we have integration sign. So we need to integrate. But for this term and this term, there is no integration sign. So no need to integrate, right? So to integrate e to x dx, we still use the same formula, which is integration of e ax dx, which is equals to 1 over a e ax plus c, right? So we have, after we integrate, we still have half e to x squared plus 3 because there is no integration sign, and then we still have minus half x e to x because there is no integration sign, and then plus we have constant half in front. For integration of e to x dx, we need to integrate using this formula. So we have half e to x, and after we done integrate, we put plus c at the back, right? So from here, we use this formula to get this, right? So this is the final answer, okay? But this time we integrate using integration by parts formula, okay? Oh, before that we need to simplify half and half here, okay? So we have half e to x and then x squared plus 3 minus half x e to x plus half times half equals to 1 over 4 e to x plus c. So this is the final answer. And when we compare from the final answer in tabular integral method, okay, here we get the same answer, right? We can use integration by parts formula for all questions involving integration by part, but we only can use tabular integral under integration by part if we have exponential function or trigo function. Alright? Got it? Coming up next, tabular integral for repeated function under integration by parts. Okay? We will discuss example 6, integration of x squared minus 1 cos 2x dx. If you like this video, you can subscribe. Thank you for watching. Stay tuned. Bye. Assalamualaikum.